You need programs to make programs. Today we're going to be talking about developer tools, which are programs we use to make other programs. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
This week, Dave, we're thinking about what developers need when they're making programs. We're talking about developer tools. I guess let's start with, would you say is the first developer tool you need?
The most essential tool is the interpreter or the compiler. These are programs that take your higher level source code written in a language like, let's say, C or Python, and convert them into something that the machine can understand. Now, we talked about these two terms, compiler and interpreter, in a previous episode called What is a Programming Language? I'll link to it in the show notes. If you haven't heard that episode or you don't know what these terms mean, I do suggest you go listen to it first before the rest of our episode today. Anyway, you'll need an interpreter or a compiler, and they're specific to the programming language that you're working in. So for example, if you're working in C, you're going to have a C compiler. If you're working in Python, you're going to have a Python interpreter. These are programs that allow your source code to actually turn into machine code. In the case of a compiler, it does that ahead of time. It takes your source code, converts into machine code that the microprocessor understands. In the case of an interpreter, as the program is executing on the fly, we're going and providing the appropriate machine instructions. Either way, you can't have your high-level program turn into anything meaningful without a compiler and interpreter. Before that, it's just a text file. So you write your text, which is the source code of your program, and it doesn't do anything until it goes to the compiler or the interpreter.
One of the next things you're going to need is a text editor, right?
Right, so originally your program is just a text file. Where does that text file come from? A text editor. So the text editor is where you go and actually do your editing. It's where you're actually writing out the lines of your source code files. And there's going to be a lot of features that text editors are going to have to help you be more effective at writing your code. Do you need all those features? No. So those of you that use Windows are probably familiar with the program Notepad that comes built into Windows. It's the most basic text editor in the world. You can write Python or C code in Notepad, but Notepad is not going to help you a lot with actually formatting that code, making sure that you're writing it properly, making writing it a little bit more convenient. So you can use any text editor, but you want to use one that actually has some features that are going to help you. I'll give you some examples of those. Some of the most popular text editors today are things like Visual Studio Code or Sublime Text or TextMate or Atom. These are just some popular programmers' text editors. And they're going to have some more enhanced features that are really going to make writing that source code, let's say in Python or C, a lot easier. Things like syntax highlighting. That shows you, as you're writing your code, the different parts of your program, whether that be a function call or a variable declaration or a keyword, in different colors, or maybe in bold or italics, that you can really see it distinguished from the rest of the program, and you can more quickly glance through your program and get meaning out of it. It's kind of like when you're writing text for someone else to read, how sometimes you're going to indent a paragraph, or you're going to write a title in bold and in a bigger font. You do that formatting so that your text is more readable. Well, syntax highlighting makes your code more readable. So syntax highlighting is something that an advanced text editor will have. It'll also have things like code completion. As you're writing your source code, it'll give you some suggestions saying, maybe this is what you mean to write next. Maybe this is the next function call you meant to write. And that way you'll have to do a little bit less typing, a little bit less looking things up. It'll provide you some answers as you go. That's code completion. And then a lot of these advanced text editors will also have some tools for doing refactoring. That's actually going and changing some meaning, or actually going and making some significant changes across the program. I'll give you an example. Maybe there's a variable that you name something and you really want to call it something else. A refactoring tool can go throughout the entire program and rename it correctly in ways that might be a little more sophisticated than just find and replace. And there also might be parts of your program that you later want to extract and use as different parts of the program. They can do things like take a part of a function and turn it into its own function. So advanced refactoring tools in a text editor can really save you a lot of time. but the text editor needs to be advanced enough that it understands the programming language that you're working in to really have effective refactoring tools. So the more advanced the text editor, the more likely it is to have all of these tools like code completion, syntax highlighting, and refactoring. And you're really going to have a lot more of a leg up if your text editor has all these tools than if you're just working in a really basic text editor like Notepad.
So you've written your program, you've compiled it, and now you're going to use your debugger.
Yeah, so you have the text editor and the compiler, the interpreter. That's enough to actually do all your work. So you could actually stop there, and there are people who write their programs just with a compiler and a text editor. The compiler will tell you if there's any problems when it's trying to convert your source code into machine code. And then when you run the program, you'll see, is it giving you the right output? And you could put some print statements inside your program to let you see how things are functioning as it's running. So actually, you have enough at this point to get started. And some people actually stop there and that's all they use. But there's tons of other developer tools to help you along the way. And the next most important tool is what's called a debugger, as you mentioned. And what a debugger does is you already have written the program and now you're running it and you want to catch some of the bugs. You want to maybe step through it. Some things a debugger can do. You can set what are called breakpoints. That's a point in the program where you want to stop and maybe inspect what the variables are. Inspect what values they're holding. Look through your program step by step. You can do that with a debugger. Other things a debugger can do are actually check exceptions or problems that happen during your program, automatically stop. Instead of the program crashing, you can go and see what's going on at the point that the problems happened. So a debugger is really going to help you more easily find, catch, and fix problems in your program. And debuggers are one of the most essential tools that any good programming language has. So a lot of the same companies or open source organizations that make compilers will also make debuggers for the same tool set.
Debuggers definitely sound super important and really useful. One of the next things you might use is a profiler. Can you tell us a little bit about what that is?
So a profiler is a little bit different than a debugger. Instead of trying to find bugs that are explicit bugs like logic errors or things that are really not working correctly, a profiler is more about resource usage. So it tells you, well, how much memory is your program using? And it might tell you how much CPU time is it using? How taxing is it on the graphics hardware or the CPU? And a profiler can actually go and tell you the specific parts of your program that are using the most resources. So you start your program, the profiler starts recording, and then at some point you stop the program, stop the profiler, and it has a trace of everything that was happening while the program was running. And you can go and look and see, well, this function that I wrote is really using a ton of memory, or this variable is just exploded, or this variable is being duplicated so many times, it really doesn't make sense. So you can really see live as the program is running, and then later on as you play back the recording, what parts of your program are really being resource hogs. And that's going to allow you to better optimize your program and focus in on the parts that need optimization.
And sometimes you might use a linter. What's that?
So a linter helps you format your code. So some of the tools in the text editor are going to help you do this. Things like auto indentation, things like the refactoring features that we mentioned earlier. But what a linter is going to do is automate the process. So you don't even need to think about, well, this is the type of capitalization I should be using here, or this is where I should be putting in spaces between my comments and the rest of my code. A linter is going to go and fix those things for you. It might even point out some problems in your program. Some of them related to formatting. Some linters go even beyond formatting. So a linter is going to really automate the process of making things a little cleaner.
One of the most important things that I've heard you talk about, both in terms of your classes and the programming that you do as an individual, is the documentation. Can you talk a little bit about that?
Yeah, I would say the documentation maybe should have been even higher on our list in terms of the order that we went through things. Documentation is critical. Documentation tells you about how the programming language works. It tells you about the standard library of the programming language, but also all the third-party APIs and libraries that you use should have good documentation as well. For example, let's say you're going to write an app for iOS. Well, you're going to need information about how all the different APIs on iOS work. How do I create a button? How do I save a file? How do I communicate across the network? Those are all going to be calls to APIs that are built into the operating system, calls to frameworks that Apple builds and lets developers use. Without good documentation, it's going to be very hard to figure out how all those things work. It's
like notes to the programmer.
It's notes to the programmer about all the different APIs, all the different libraries that are available to them.
And remind our listeners what an API is.
API stands for Application Programming Interface. It's basically like something that's already built for you that you can use from your program that gives you some functionality. So for example, there might be an API that says, I want to create a button and I want it to be this part of the screen and look like this. Or there might be an API that says, I want to make a network connection to this website and download this data from this website. So it's like pre-built functionality that you can access from your program so you don't have to reinvent the wheel and recreate that functionality. So APIs are everything today. I mean, it's very rare that you're going to be working in raw metal and doing everything from scratch. A lot of your program is going to be you calling APIs that other people have built, and those APIs need to be well documented so that you know how to use them. So documentation is actually one of the most critical tools, and it comes in many different forms. The original vendor of the APIs or the libraries is often going to provide the documentation. So for example, in my iOS example, all those frameworks that Apple creates, things like Cocoa Touch or Swift UI, are going to have extensive documentation on their website. However, another form of documentation is books. You might know that I write programming books. I don't write documentation books. I write books about how to solve problems in programming languages or how to learn programming languages. But there are a lot of books out there that are just about, well, this is how you use these APIs. This is how you use this programming language. This is how you use the standard library that comes with this programming language. Those formal books are better vetted than some of the resources you'll find online. But of course, today, a lot of programming, for better or for worse, is going to Dr. Google and looking up, how do I use this API? And you're going to find some answer on Stack Overflow, or you're going to find somebody's blog post about it. And those can be really helpful. They're not as formal, they're not as vetted as something that would come through a traditional publisher or something that usually comes from the original vendor. But they're really helpful in that pinch when you need to know something very specific or you just want to get a really quick answer. So the combination of all these resources are essential tools. Documentation from the original vendor, formal books are often helpful, and then of course using Google or another search engine to find things on blogs and on Stack Overflow. The combination of these is where we actually get the information that tells us this is how we can put these APIs together to create something that's useful for our program.
And how does all of this relate to integrated developer environments? And what are those?
So integrated developer environments, or IDEs, are pieces of software that combine all of these previous tools that we've been talking about. So generally an IDE is going to contain a text editor. It's going to contain a hookup to a compiler. It's going to contain a build system. And we didn't even talk about build systems, but build systems are tools that go and take your various compiled components and put them together into a single binary that's going to give your libraries, your own code, maybe some of your assets all together in one package. And a build tool is going to package things up for you and make sure that they can all work together. But anyway, so an integrated development environment is going to contain these build tools. It's going to contain a way of interfacing with the compiler or the interpreter. It's going to contain the text editor. It's going to contain an interface to the debugger. It's going to contain an interface to the profiler. It might have a built-in linter. It might even have a window that shows you documentation, and you can even just click in a part of your program and instantly see that documentation. So it tries to make the whole development experience a lot more convenient. And some people like to work in IDEs, and some programmers like to work with all these tools piecemeal. So they like to use a separate text editor, a separate debugger, separate compiler, without having them all packaged together in one place for them. There's nothing that you can do in an IDE that you couldn't do using the separate tools. It's just a matter of convenience and which interface you like better. Some programmers say they find the IDEs overwhelming, or they like to almost create some of their own tools and not use the tools that come built into IDEs as much. So some people really prefer the more piecemeal approach, but over time, the progression has been towards IDEs. So whereas 30 years ago, maybe IDEs weren't that common, over the last couple decades, most programmers generally work in IDEs. There's becoming more and more of a fuzzy line between IDEs and text editors because text editors have been getting more and more features. I'll give you a really specific example. Microsoft makes two different development environments. One is called Visual Studio, which is a full IDE, and another is called Visual Studio Code, which is one of the most popular text editors today. But there's so many plugins for Visual Studio Code, And there's so many built-in features to Visual Studio Code that it is almost like an IDE too. It's just like more of a lightweight IDE almost. So it can be used almost as an integrated development environment, even though it was originally designed as a text editor. So the line between the two, as text editors have become more sophisticated, has started to blur. But I'll just mention a few of the IDEs that people might be familiar with. Visual Studio from Microsoft, I already mentioned. Apple's flagship IDE is called Xcode. And then the company JetBrains makes a lot of really popular IDEs that are specific to particular programming languages. Things like PyCharm for Python or Golang for Go. They've really cornered the market on kind of IDEs not produced by the big tech companies. They're kind of filling a lot of the other niches. So you have a choice. You don't have to use an IDE, but often an IDE is very convenient because it puts everything in one place.
And there are some other tools that we haven't talked about here, but still might be useful for developers.
Yeah, there's tons of other kinds of developer tools. I'll mention a few other categories of them, but we won't go into them. Deployment and testing tools. So how do you make sure that new builds of your program are getting out to beta testers and that they're actually able to give you feedback and run them? That your program is packaged correctly for the App Store. That might be a deployment tool. Media tools. So you have audio, visual, media that's going to go into your program. Is it formatted properly? Is it as compact as it possibly can be? There's tools for making sure that those things are true. Static analysis tools are things that can check, is your code actually right before you even compile it? So they can tell you ahead of time, hey, there's something here that might cause a problem, and let you fix that before you even get to the compilation stage. So and these are just scratching the surface. There's tons of other kinds of developer tools, but really the most essentials are the ones we mentioned at the beginning. You must have an interpreter or compiler, and you must have a text editor. That's the bare minimum. After that, it's very helpful to have a debugger. Of course, you're going to need documentation if you want to be productive at all, and a profiler or a linter, and maybe an integrated development environment really take things to the next level. So you don't need every one of these tools, but most people who work in professional software development use all of them.
Well, now that our listeners know all the tools, they can go out there, get them, and start programming.
Yeah, and you can listen to our previous episode called Learning to Code, and I'll link to it in the show notes if you found this topic interesting and you want to start writing your first program. All right, well, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll see you next week.
Bye.